Hello all, I'm Kritika Garg from Web Science and Digital Library Research Group at Old Dominion University. Today I'll be talking about our work on optimizing archival replay by eliminating unnecessary traffic to web archives. We discovered some replayed web pages that causes recurrent requests leading to unnecessary traffic for the web archive. For example, this is a regular Memento replaying in the browser. What you don't see here are the abandoned requests it's making to the web archive server. We can see the network activity of the Memento using Chrome Developer Console, where it shows how many requests it's raking in. Since these requests are not visible to the user, if user leaves such Memento running on the browser and goes out for coffee or something, they'll be unaware that their browser is continuing to generate traffic for the web archive. For example, this Memento is making 945 requests per minute on average. We found that web pages of sites like radio, sports, etc., that require live or regular updates, and web pages that contains image carousels, widgets, etc., are more likely to make recurrent requests. As you can see in this Memento, there are carousel trying to load embedded images. However, these images are missing from the web archive and the live web. So we get the HTTP error response 404 not found. Since the Memento doesn't get successful 200 OK response from the server it's looking for, it's making requests for the images again and again. Some web archive may try and patch these missing embedded resource by requesting the live web. If the requested resource are not available on the live web, the resource cannot be archived, and the response remains 404 not found. In that case, patching the archive from the live web will create unnecessary writes and read. Some Memento would continue to poll the server as frequently as they did on the live web, while some would poll even more frequently if their requests are 404, creating a high amount of unnecessary traffic. On a large scale, such Mementos could potentially cause security issues, such as denial of service attacks. To study this behavior in isolation, we created a minimal reproducible example web page containing carousel that make requests for 3 missing images every second. These images are not available, and we receive HTTP 404 responses for them. Then we archive this demo webpage locally using PyWayback, which is a Python web archiving toolkit. The Memento replaying here is requesting for the missing images. We can see the web server logs in the terminal and how there are requests made to server every second. To optimize this replay, we use Nginx proxy server and added cache control HTTP response header to cache 404 responses, so that the cache response could be reused in the subsequent request. In this case, cache control header is set to public. Now you can see here, even though web page is making recurrent requests for the images, it's not hitting the server anymore. Since the response is cached, we can see there are no additional requests in the web server logs as we saw before. So to summarize our work, replaying an archived web page should not cause 1,000 requests per minute to the web archive. And web pages that require regular updates, for example, radio, sports, etc., containing image carousels are more likely to make recurrent requests. Web archives trying to patch 404s from live web may cause even more unnecessary traffic to the web archive. On a large scale, such Memento could cause a possible security issue. In this work, we propose a solution of optimizing the replay by setting the cache control response header to cache 404 responses. Thank you.